Okay, so we're going to try to use Desmos here when we're trying to determine whether these tables are linear or whether they're exponential, nonlinear. In the future, we'll be determining if they're quadratic, but these are just exponential, linear, or neither of the above. So we're going to go from negative 1/4 to 1/2. That means I subtracted I added a half. I'm sorry, 1/4. So that's 25 cents to 50 cents. I added a quarter. I added a quarter. Did I add a quarter to a half to get to 1? So that's no. So we know this is not linear because it's not consistent by addition or subtraction. But 1/4 times 2, so a quarter times 2 is going to give me that 50 cents. So times 2. And then 1/2 times 1, so 50 cents times 2 will give me 1. 1 times 2 will give me 2. 2 times 2 will give me 4. And 4 times 2 will give me 8. So we know this type of function is going to be exponential because it is consistent multiplication all the way through as it doubled. So it doubled would be your keyword here. Now, to write your rule, ultimately you should see that when x is 0, y is 1. So that is your red flag that this is your y-intercept. And remember, as an exponential function is y equals a times our rate of change raised to the exponent x. So the variable is in the exponent spot. So your starting point would be 1, which would be your a value. Y equals 1. Our b value is at 2 because it doubles, raised to the x power. Now, how to use Desmos to do this for you, and also just to see what it looks like visually in the event you're a visual person. We're going to add a table, and we're going to put in our values. So -2, -1, 0. Whoops, that's not it. Sorry. 0, 1, 2, 3. And we're going to put in 1/4, 1/2, 1, 2, 4, and 8. Now, just looking at this here alone as is, you should see that this is a positive exponential function because you can see that curve. And you see that it touches the x-axis at 1. Now, to get the rule, just like you did linear equations back when you're finding line of best fits for linears, we're going to do y1. And then you are going to hit ABC, which is down here behind this thing, and it's not going to let me hit it. Ooh, let's see if I can move it. Yeah, move that there. So hit ABC. You're going to have a squiggle mark, and it is A times B, and you can plug that in parentheses, or you can put that in a multiplication symbol there. And then we're going to raise it, to the x power. And you could do that by using your up caret, which is shift 6, and then a 2. Or if you go back to your numbers here, this a to the b is how you get it up in that portion up there. And then we add a 1 here. And notice before I added that 1, nothing happened. So if nothing's happening, I would venture to bet that you forgot your 1s and your 1s. And just like with our linear, that's just noting that we're using these x values and these y values to get this line of best fit. So our r squared is a positive 1, so that means it is super strong and went through all the points and definitely is exponential. Our a value is 1, which we had over here. Our b value is 2, which we already had over here as well. But you can see that this work goes perfectly through all those dots. Again, you can see your y-intercepts. You can see all your coordinates if you should choose to find them all the way through. If I hold down, I can find it a little bit better. So there we go, that 2 and 4. But this is how you can visually look at it from your tables if you have to choose. All right, so from -4 to -2, it looks like I added 2, and I always check the addition or subtraction first because linear is everyone's favorite because you've had the most experience. So -2 to 0, we added 2, add 2, add 2, add 2. So it is consistent by addition of 2 for every per x value increase. And again, as I talked about yesterday, make sure these are increasing by 1 and not jumping in any form or fashion, because that's 2 over 1 for your rate of change. So this is a linear function. It is a positive linear function as well, which is going to matter because those y values are growing as my x values are growing. So again, if you go find your 0x value when it's given, we know that y is 0. So in this case, our y equals mx plus b form. From our table, hopefully we see that 2 is our slope, or it's 2 over 1. There's no b value because it's 0, 0. So y equals 2x. Now, You can come back over here again. And we have negative 2 to 3 still, so we're just going to change our output value so that negative 1/4 becomes a negative 4. Then we get a negative 2, 0, 2, 4, 6. Now, as you see, this exponential function definitely does not touch these lines. And you can also see that it has that constant rate of change of rise 2, run 1, rise 2, run 1. So we're going to come down here. We're going to change this from an exponential function. And so it's going to be y sub 1 squiggle mark, which you did get, again, from going to ABC here. And it's down here. Right there's your squiggle mark. And then we're going to do mx. We have to add a 1. And then plus b. Again, our r squared is a positive 1, which means it is a positive, perfectly strong linear, so perfectly linear correlation with all this data. Our m value is 2, and our b value is something ridiculously small, because that 10 to the negative 18 just means that decimal moves way to the left 18 times, and that is as good as 0. So in this case, it is as good as 0 for sure. So our m value is 2, and this is definitely 0, because it's really 0.9065649, which in the case of graphing is 0. So we have our linear function. All right, so we'll go again. So 1/16 to 1/8 means we added 1/8, and then from 1/8 to 1/4, we did not add 1/8, or we didn't. There's not addition that's happening consistently. So from 1 to 2 would be add 1, and that's an easier one maybe if you're not a fraction person. 1/2 to 2 to 1/2 to 1 is not adding 1. So even using your whole numbers down here, no, this is not linear. So we definitely know it's not linear. So we're going to check. So from 1 to 2, that would be multiplied by 2, right? So if we're checking it to be exponential, 1/2 to 1 is multiplied by 2, because that's 50 cents to $1. 25 cents is a quarter, or 1/4, so that's going to be times 2. If I multiply 1/8 times 2, so 1/8 times 2 over 1 does give me 2 over 8, which is reduced to 1 over 4. So that is also times 2. And 1 over 16, again, is going to be times 2 as well. So we know it's multiplied by 2. So again, it's another double. It's doubling as our rate of change. And it is an exponential function. So we're going to get our rule straight from over here in Desmos this time, instead of even talking about it. Otherwise, you do have your 0 there, so you could ultimately just write it from your table if you remember all your parts and how to be able to pull it. And if that 2 is easy to find, so let's say you didn't know what that rate of change or what the multiplicity is, or if it doubled, or if it halved, or if it was addition, or any of those fun things, you can still come over here as long as it is a calculator active question, which is all I'm going to give you for the most part, or at least for our quiz. Over here and plug it in and check it out. So 2 was 1, and at 3 we had a 2. So you can see here, again, we have a slight curve. It's a positive exponential function, definitely not linear. So we're going to go down here and we're going to change our rule, or our equation. So rule and equation are interchangeably used to mean the same thing. So we're going to do A, and then you can use times, which is down here, times B. And then, like I said, you can use AB to get that X to the top. Make sure you get a 1. Now we have all our information. It crosses through perfectly. We see that r squared equals 1, which means it is absolutely 100% an exponential function. Our A value is 0.25, which is that 1/4, which you see over here where X is 0. And then our B value is 2, and that's because it's doubling all the way across. So then our equation is going to be Y equals 0.25, or we could put 1/4 doubled raised to the x power, because that's what makes it exponential. All right, guys, I hope you understand good enough how to put these in Desmos. If you have questions, please don't hesitate to come to tutoring, live class, or email me, but definitely get comfortable using your Desmos to put these in and to put in those functions. So line of best fit, even for a function that looks exponential, not just linearly. So you can write these equations by using y1 squiggle a times b raised to the x 1. Again, your 1s are the big call-outs, so most people get messed up. So just remembering the formula or the outline for an exponential function is the key to this this excitement. All right, guys, thanks for watching.